Welcome to Lost at 3 a.m. Put your phone down, close your eyes, and let this be the last video you hear tonight. Relax, breathe, and let's begin. Tonight, we're exploring the fascinating world of time zones and clocks, a system so familiar, yet so complex, that it quietly shapes the rhythm of our lives every single day. Timekeeping has guided human civilization for centuries, influencing everything from travel and trade to the way we organize our daily routines. But time isn't as straightforward as it seems. Around the world, time zones shift by hours, half hours, and even strange 45-minute increments. There's a line where today and tomorrow meet, and ancient clocks once measured time using nothing but the flow of water. As you listen tonight, let your mind drift as we journey through the story of how the world keeps time, one tick of the clock at a time. Let's begin. Time zones are the invisible lines that divide the world into regions where the time of day is synchronized. They were created to solve a surprisingly complex problem: how to measure time across a planet that's constantly rotating. Before time zones existed, each town and city measured time based on the position of the sun. Noon was simply when the sun was highest in the sky. This worked well for small local communities, but became complicated as travel and communication expanded. When trains began crossing countries, it became clear that a standardized system was needed to keep schedules consistent and avoid confusion. The concept of time zones emerged in the 19th century, largely thanks to the expansion of railroads and global trade. The Earth rotates once every 24 hours, which led to the idea of dividing the world into 24 primary time zones, each covering about 15 degrees of longitude. Each zone represents 1 hour of difference from its neighbors, aligning with the natural progression of sunrise and sunset as the planet turns. At the center of this system is the prime meridian, a 0-degree longitude line that runs through Greenwich, England. From there, the world's time zones are measured forward or backward, with places like New York falling behind Greenwich and Tokyo ahead. The further you travel east or west, the greater the difference in time. While the idea seems simple, the way time zones work can be quite fascinating. Some countries, like China and India, use a single time zone despite their massive size, while others, like Russia and the United States, stretch across multiple zones. Some regions even have time zones offset by 30 or 45 minutes instead of a full hour, creating unique local variations in how time is measured. Time zones help us stay connected in a synchronized world, whether it's for global business, travel, or simply calling a friend on the other side of the planet. Yet they also remind us how vast and diverse our world truly is. Different sunrises, different nightfalls, all happening together in the flow of time. As you close your eyes, imagine the Earth slowly turning, the sun rising in one part of the world while stars begin to twinkle in another, all moving in harmony through the endless rhythm of time. The prime meridian and Greenwich Mean Time, often referred to as GMT, lie at the heart of how the world measures time. This imaginary line, running through Greenwich, England, marks 0 degrees longitude, the starting point for dividing the world into time zones. Before the prime meridian was officially established, different cities around the world kept their own local times based on the sun's position. However, as global travel and trade expanded, this lack of coordination created confusion, especially with the rise of railways and transatlantic shipping. Imagine trying to schedule a train where every station measured time differently. Chaos. In 1884, the International Meridian Conference was held in Washington, D.C., where it was decided that the prime meridian would run through the Royal Observatory in Greenwich, England. This decision wasn't random. Greenwich was already a hub for maritime navigation, and British maps commonly used it as a reference point. From this line, the world's time zones would be measured in 24-hour increments, moving east and west, each representing 1 hour of difference. Greenwich Mean Time itself was the standard by which the world measured time for over a century. It's based on the mean solar time at the prime meridian, essentially tracking the average position of the sun throughout the year. GMT became the foundation for global coordination, used in everything from shipping schedules to early telecommunications. Today, GMT has been largely replaced by Coordinated Universal Time, or UTC. UTC works similarly, but uses atomic clocks for even greater precision. However, the prime meridian in Greenwich remains symbolically important, and you can still visit the Royal Observatory to stand on the line where time begins. Or, more accurately, where global timekeeping was standardized. The prime meridian isn't just a line, it's a reminder of how human civilization has worked to create order in the vastness of space and time. As you drift off to sleep, imagine the quiet tick of a clock in the Royal Observatory, marking the passage of time in perfect rhythm with the turning of the Earth. The international dateline is one of the most fascinating features of global timekeeping, marking the invisible boundary where today becomes tomorrow. This imaginary line, running roughly along the 180th meridian in the Pacific Ocean, serves as the point where the date changes by an entire day. The purpose of the International Dateline, or IDL, is to keep the world's time zones synchronized. Because the Earth rotates from west to east, travelers crossing the line experience a shift in their calendar date. If you cross the IDL from east to west, you gain a day. If you cross from west to east, you lose a day, as though time itself reset. However, the dateline isn't a perfectly straight line. To avoid splitting countries and islands between two different calendar days, the line zigzags around certain regions. For example, the nation of Kiribati made a historic change in 1995, shifting the line eastward so that all its islands could share the same day, making it one of the first places to experience each new year. There are also fascinating quirks. The Diomede Islands, located between Russia and Alaska, lie just a few kilometers apart, but are separated by the IDL. This means that while Big Diomede, Russian territory, is nearly a full day ahead of Little Diomede, US territory, the islands are so close you could see yesterday from the shores of today. The International Dateline serves as a reminder of how humans have tried to bring order to the vast complexity of our planet's rotation. While time itself moves steadily, our attempts to measure it have created unique boundaries where the present, past, and future can feel strangely connected. As you drift off tonight, picture the vast Pacific Ocean, calm and endless, with the line where today meets tomorrow, stretching quietly across the waves, reminding us that time, while structured, remains a beautiful mystery. Time zones may seem straightforward, but around the world, there are some truly unusual ones that break the standard hour-by-hour divisions most of us are familiar with. While most time zones shift by full hours, some countries and regions follow unique offsets, creating fascinating exceptions to the standard global system. One of the most famous examples is Nepal Standard Time, which is set at UTC plus 5 hours and 45 minutes, making it one of the only countries in the world with a time zone offset by 45 minutes rather than a full hour. This unusual setting is tied to the meridian passing near Nepal's capital, Kathmandu, emphasizing local astronomical positioning rather than international norms. India also operates on a unique half-hour time difference. Indian Standard Time, IST, is set at UTC plus 5 hours and 30 minutes. This offset was chosen to create a single time zone across the entire country despite its vast size, keeping the entire population on the same schedule. Another unique example is Newfoundland time zone in Canada, which is set at UTC minus 3 hours and 30 minutes. This small deviation allows the island of Newfoundland to stay more closely aligned with solar time, even though the rest of Canada follows standard hourly divisions. Australia also features some irregular time zones. The state of South Australia uses UTC plus 9 hours and 30 minutes, while some regions of Western Australia and the Northern Territory maintain slightly different offsets, further reflecting local variations. These unusual time zones show how flexible and complex global timekeeping can be, shaped by geography, politics, and history. They remind us that the concept of time, while standardized, is often adapted to fit local needs, balancing science with cultural identity. As you drift off tonight, imagine the quiet ticking of clocks across the globe, each marking time in its own unique rhythm, some shifting by minutes, others by hours, yet all moving in perfect harmony as the Earth turns. Daylight saving time, often called DST, is a seasonal adjustment of the clock where time is shifted forward by 1 hour during the warmer months of the year. The goal? To make better use of natural daylight by extending the evening hours, reducing energy use, and encouraging outdoor activity. The idea of adjusting time based on daylight isn't new. Ancient civilizations like the Romans used different timescales depending on the season. However, the modern concept of DST originated in the early 20th century. It was first proposed by George Hudson, a New Zealand entomologist, in 1895, and later popularised by British builder William Willett in 1907, who advocated for shifting the clocks forward to make better use of summer daylight. The first major implementation came during World War I, when Germany introduced DST to conserve fuel by reducing the need for artificial lighting. The practice was later adopted by other countries, including the United States and the UK, as a wartime energy-saving measure. It returned during World War II and became more widely adopted in the following decades. However, not all countries observe daylight saving time, and those that do often disagree on its effectiveness. While some regions benefit from longer evening hours for outdoor activities and lower energy costs, others argue that the practice disrupts sleep patterns and provides minimal modern energy savings due to widespread use of efficient lighting technology. Interestingly, some countries have abandoned DST altogether. Japan, for instance, no longer observes it, while countries closer to the equator, like most of Africa and Southeast Asia, never adopted it, since their daylight hours remain fairly consistent year-round. In the US, states like Arizona and Hawaii have opted out of DST, keeping the same time all year long. Meanwhile, in Europe, discussions continue about potentially ending the practice altogether, with debates focusing on whether permanent standard time or permanent DST would be more beneficial. Daylight saving time reminds us how fluid our concept of time can be, how clocks are adjusted not just by the rotation of the Earth, but by human decisions aimed at balancing energy, daylight, and productivity. As you drift off to sleep tonight, imagine the sun rising a little earlier, the evenings stretching longer, and the quiet rhythm of the seasons gently shifting the pace of time itself. Some countries are so vast that they stretch across multiple time zones, making them feel like several worlds within one. The division of time zones in these countries is shaped by geography, politics, and history, with some nations spanning more zones than entire continents. Russia holds the record for the most time zones in a single country, covering 11 separate time zones from UTC +2 in the west to UTC +12 in the Far East. This massive spread means that while it may be morning in Moscow, it could already be nighttime in Vladivostok. The sheer size of Russia requires this many zones. Yet, interestingly, the country once reduced its time zones from 11 to 9 in 2010 before reverting back to 11 in 2014. The United States spans 6 time zones across the mainland and territories: Eastern, Central, Mountain, Pacific, Alaska, and Hawaii Aleutian. Each zone reflects the vastness of the country, with states like Texas and California operating hours apart from each other. Some regions, like Arizona, do not observe daylight saving time, creating even more variation. China, despite being geographically massive, operates on a single time zone, China Standard Time, UTC +8. This decision was made for national unity, meaning the entire country follows Beijing time, even in far western regions like Xinjiang, where solar noon can occur hours later than the official time. France also spans multiple time zones, not because of its mainland, but due to its overseas territories. From the Caribbean islands of Guadeloupe to the Pacific archipelago of New Caledonia, France officially covers 12 time zones, more than any other country when including overseas regions. Other countries with multiple zones include Canada, with 6 time zones, and Australia, with 3 primary zones, though some regions adjust further with half-hour differences. The existence of multiple time zones within a single country highlights the vast diversity of landscapes and cultures contained within national borders. While timekeeping creates order, it also reveals the incredible scale of the world we live in. As you drift off, imagine the quiet rhythm of clocks ticking across the world, some just beginning the day, others winding down for the night, all moving together, yet slightly apart in the gentle flow of time. Clocks have played a crucial role in human history, helping us measure and organize time long before the invention of modern technology. From ancient mechanisms powered by water to massive public towers chiming across cities, clocks have evolved in fascinating ways across civilizations. One of the oldest known timekeeping devices is the sundial, dating back to ancient Egypt around 1500 BCE. Sundials measured time by the position of the sun's shadow cast on a marked surface, working only during daylight hours, but laying the foundation for future mechanical clocks. In ancient China, the Su-song water clock from the 11th century was a marvel of engineering. It used flowing water to drive a complex system of gears and weights, keeping remarkably accurate time for its era. Meanwhile, Islamic scholars in the medieval period developed highly advanced astronomical clocks, blending timekeeping with celestial observations. In Europe, the rise of mechanical clocks transformed public life. The Prague astronomical clock, built in 1410, still operates today, with intricate dials displaying not just time, but phases of the moon and the positions of the sun and stars. Similarly, Big Ben, the iconic clock tower in London, has been marking the passage of time with its powerful chimes since 1859. Some clocks were designed to be more than just functional. They were works of art. The Strasbourg Cathedral clock in France is a masterpiece of both design and mechanics, featuring moving figurines that perform a show at each hour. The invention of the pendulum clock by Christian Huygens in the 17th century brought newfound precision, leading to the development of modern grandfather clocks and public clocks that kept towns synchronized. Today, the most accurate clocks in the world are atomic clocks, which measure time based on the vibrations of atoms. They are so precise that they would lose only a second every 100 million years, and are used to regulate global time standards and technologies like GPS. Clocks remind us that time has been measured in countless ways, yet its rhythm has remained constant, marking moments, guiding our days, and connecting us across generations. As you close your eyes tonight, picture the gentle ticking of an old wooden clock, the sound fading into the quiet rhythm of time passing, steady and peaceful. The atomic clock is the pinnacle of modern timekeeping, providing unmatched precision in measuring time. Unlike traditional clocks that rely on mechanical parts, atomic clocks measure time by observing the vibrations of atoms, making them accurate to a degree almost beyond imagination. At the heart of an atomic clock is the element cesium-133. When cesium atoms are exposed to microwave radiation, they oscillate at an incredibly consistent frequency, 9,192,631,770 times per second. This precise vibration is used to define the length of a single second, forming the foundation for Coordinated Universal Time, or UTC, the global standard for time. The accuracy of atomic clocks is so extraordinary that they would only lose 1 second every 100 million years, far more precise than any mechanical clock. This precision has made them essential for scientific research, navigation, and even space exploration. Atomic clocks play a vital role in GPS technology. The satellites orbiting Earth are equipped with atomic clocks to ensure pinpoint accuracy in location tracking. Since GPS systems rely on measuring the time it takes for signals to travel between satellites and receivers, even the slightest error in time could lead to major inaccuracies in positioning. These clocks also help scientists study gravitational time dilation, a concept from Einstein's theory of relativity. Atomic clocks placed at different altitudes on Earth have shown that time moves slightly faster at higher elevations where gravity is weaker, proving the fascinating link between time and gravity. The strontium atomic clock, one of the latest advancements, is even more precise than the cesium standard, with the potential to redefine global time standards in the future. While atomic clocks operate on the cutting edge of technology, they remind us of something deeply ancient: the desire to measure time with absolute precision. From the shadows of sundials to the vibrations of atoms, the quest to measure time continues to evolve, yet the steady rhythm of the universe remains unchanged. Time is one of the most mysterious and constant forces in our universe. It connects us all, yet it flows differently across the world, measured by shifting time zones, ancient clocks, and the rhythmic turning of the Earth. Though invisible, it shapes every moment, from the rise of the sun in one part of the world to the calm of midnight elsewhere. The systems we've explored, time zones, the prime meridian, the international dateline, and atomic clocks, are all human attempts to bring structure to this vast, unstoppable force. Yet, even with all our precision, time feels deeply personal. It marks beginnings and endings, milestones and memories, yet always moves forward, steady and unchanging. What makes time so beautiful is not just its measurement, but how it connects people across the globe. The sun setting over the Pacific waves while it rises over European mountains. The quiet tick of a clock tower echoing through a small village, while digital atomic clocks pulse silently in the background of modern life. As you rest tonight, let go of the need to measure every second. Time will continue its quiet rhythm, steady as the stars above. Let the ticking fade, the rhythm soften, and allow yourself to drift into the timeless calm where all is peaceful and the world simply turns. Thank you for spending your evening with Lost at 3 a.m. Sleep well, and may your dreams be filled with calm, endless horizons where time slows and peace lingers.